Remember this EEPROM programmer, which I made a whole video about a week ago? Never mind the little extension over here. Well, today we will be talking about the fruit of this EEPROM programmer, the computer. So basically what this is just a simple computer based on a 65C02 processor, and this is the exact same sort of computer that Ben Eater designed in his series, and it is running a program. So if I plug this in and press the reset button, it blinks the LEDs. Well, sometimes it freezes, but yeah, hopefully you can see all those LEDs blinking. Never mind the fact that some of them are dim. This display is absolutely terrible. But anyway, it's running a program. And the crazy thing, the program is stored on this chip, which of course has to be programmed by this EEPROM programmer. And if you're wondering what this little display is, it's so that I can more easily program this thing. So if you're wondering how I get a program that is written on a computer into an EEPROM that is in a terrible computer, then, well, let me walk you through step by step. So first, I write the program in Microsoft Notepad. Then I take the program and use a set of very cryptic commands to turn it into a file that this computer could, in theory, read. Then I take this program over here and import it into a hex editor to copy it into a hexadecimal form. Then I take that hexadecimal form of the file and import it into Microsoft Copilot so that I can convert it from hexadecimal into binary. Then I take that binary output of Microsoft Copilot and import it back into Notepad, where I change the size of the font so that it can be written in just the correct way onto a strip of paper. And then I will take that strip of paper, feed it through the EEPROM programmer so that I can program the EEPROM, and then I can take the EEPROM out, put it in the computer, hit reset, and the computer will do its thing. Yeah, about that strip of paper, let me see if I can find it. This is the piece of paper that I used to program my EEPROM. Does this remind you of anything? Yeah, this is basically just a punch card. The way that I did it is I basically fed it through one byte at a time, and it was a very slow and tedious process. And basically the way that this worked is that the lights were shining through, and each black spot represents a 1, and each blank spot represents a 0. So if I saw any error, then I would correct it. And I could also just program it one bit by bit this time. And this is actually why I added this little secondary display on the sides. That way I could just have my piece of paper and feed it through bit by bit using a little Lego contraption on the side that I could just slowly turn a handle, and it would and then would slowly feed the paper through. And also, these LEDs right here are a lot better for this application than the ones that I used over here. These right here are SMD LEDs, if you can see, and they do not have any sort of reflector, so they basically just produce a wide splash of light. Some of these LEDs in here actually do have a proper little lens and a reflector, like those two over there, which I only used because I had ran out of these ones. But these ones produce a wide splash of light. These ones produce a much clearer dot of light, which is, of course, much better for this paper so that it blends together a little bit better. And also, Do you see something wrong with this picture? Look at these resistors. Some of these are burned. Their legs are cut super short. There's solder everywhere, and it just looks terrible. These are all 10K resistors, which is quite a high value to drive an LED with, but I just chose that because that was literally the only value that I had multiple of them on hand, and these white LEDs can light at a very low current. But the thing is, this does mean that the LEDs are super dim. So if I turn this thing on, and turn my power supply on, you can see the LEDs light. It's actually significantly brighter in the camera than it is in real life. If I turn this thing off, it does actually look quite bright. Even when I put this thing on, you can still see two very distinct dots of light. It's surprising. This camera is a lot better than my eyes in this case, but yeah, it's not really working all that well. Funny enough how you can actually see a faint glow from all of the other surrounding LEDs. But anyway, I'm getting significantly sidetracked. I was supposed to be talking about the computer, not the thing that I used to program the computer. So let's go ahead and take a closer look at the computer. So of course, this thing right here is the display. It is made up of 8 red LEDs, which are, each one of them is connected to a pin, and this one right here is the current limiting resistor. It's not really the best idea to have a single current limiting resistor for 8 LEDs, because if all 8 are lit, then they're all going to be extremely dim, and if one is lit, then it's going to be extremely bright, but at least this prevents the LEDs from burning up. But apparently these LEDs are cheap, I guess, so I guess a couple of them have already failed. This section right here is the power supply. It's just a standard mains input jack, a capacitor, and a voltage regulator. This is your reset circuit. It has this little button over here and a pull down resistor. Actually, I forget whether... Oh, this is a pull up resistor, yeah. So it basically just keeps it at 5 volts most of the time. Then when you press it, it turns to 0 volts, and when you release it, it jumps back up to 5 volts. And that little 0 volt section is going to be where everything, all the registers and stuff reset. And this little resistor that's under here is just the current limiting resistor for the indication LED. This section right here is the clock circuit, which uses a 5x5 timer, a potentiometer, which I took from an old soldering iron, and then a couple like resistors and capacitors and an inductor to produce a fairly clean square wave signal. This inductor right here was just to smooth out any ringing, but unfortunately it also increases the rise and fall time of the clock signal, so it's significantly less sharp, and it's probably not the best for the registers and stuff, but oh well. Anyway, let's go inside, deeper inside. Of course, this is the microprocessor, which of course is the brains of the system that executes all the instructions with like ALU and registers and what else. This right here is of course the EEPROM. It is a AT28C16, or just a regular 28C16. There's not really any difference. It's just that this one is made by Atmel. Well, this one probably isn't made by Atmel because I bought it off the AliExpress, and it's probably a fake chip, but it still works just fine, so I can't really complain. But this thing is only 2 kilobytes, and Ben Eater's chip was 32 kilobytes. So yeah, this thing can store cannot store very large programs. This thing right here is a quad NAND gate, and it basically is just a control circuit to activate either the versatile interface adapter or the EEPROM, depending on what address the microprocessor is reading from. And it basically prevents a bus conflict, which is where 2 chips are trying to write data to the bus at the same time, which of course is not good. That will produce short circuits and potentially damage the chips. And of course, there's a little electrolytic capacitor right here for smoothing. And these little resistors right here that seem to go nowhere, these are pull-up resistors for hopefully some future interrupt buttons that I will put up here. And these are just these will be used later, and of course they're just connected to 5 volts over there. And these little copper wires right here are going to be the power lines. They just run all the way from the main power supply all the way down and then back around just to supply power for the entire thing. It's a pretty neat setup. I guess it's kind of like a breadboard. And then, of course, all the connections between the chips. So these wires over here would be the register select wires for the versatile interface adapter. They're kind of flimsy and flopping about, but these basically are just the address lines for the versatile interface adapter so that you're telling it exactly what to do. These little things right here are the data lines, and what I did is I hooked up 2 pin headers and then used some thick stranded core cable to connect the 2 boards. I really used a lot, and it looks like they could break off any moment, but I guess it's working fine for the moment. This thing right here, I don't really know what this is. This might be, oh yeah, this is the read-write signal line that tells whether or not, that tells the EEPROM whether or not that tells the versatile interface adapter whether or not we want to read from it or write to it. This one right here, I can't tell what this is. Maybe this is the chip select signal. Is that a clock signal? I don't really know what this wire does. So yeah. And then this wire right here, is that another? Oh yeah, that's one of the chip select signals. This one right here might also be a chip select signal. Yeah, it probably is a chip select signal, isn't it? So both those are going to be chip select. And both of these, this right here is the clock wire, which of course goes down to the CPU and also to the versatile interface adapter. The EEPROM does not need a clock signal. It's basically just a very big, bulky SD card. And this wire right here, yeah, this is the reset signal. So there's not really all that many signals. I tried to reduce the number of signals that would go between the boards to prevent it looking like a mess of spaghetti. And I mean, it still does kind of look like a mess of spaghetti, but it's a little bit of a neater mess of spaghetti. And if you're wondering why I left such a big open space, I hope to put a RAM chip over here. Go ahead and watch a couple other Ben Eater videos and put a RAM chip over here, so that I can, to perform more complex tasks. And just in case you're wondering, this RAM chip right here, I'm not abusing the AI industry by buying a single RAM chip. I mean, it's, I think I have a couple of these. Where are they? Ah, yeah, these things. So this right here, well, they're in terrible condition, I know. That's what you get from ordering crap off AliExpress. But anyway, these things right here are HM62256, which are 32 kilobyte RAM chips that you would just stick in there. And yeah, these ones right here are terrible quality, at least on the outside. I mean, I don't know what they're like on the inside. They might work just fine. They might be intermittent. They might not work at all. But yeah, I really hope that this thing would work, because I actually built an entire one of these computers a long time ago. Not just on a breadboard, I did that too, but I also soldered one up together, and I never showed it on the channel because it never really worked out correctly. This one is definitely working out a lot better, I guess because I have more experience with soldering and stuff. But the RAM chip refused to work. So I just scrapped that project and it just sits on my bookshelf. And I really hope this one won't suffer the same fate as my old one. But yeah, these RAM chips, well, these were bought before the AI craze. But anyway, these chips are probably not really all that expensive normally. Like, why would we be using bloody 62256 in an AI data center? But anyway, I think that's enough yammering on about this, about my little computer over here.